Hello, everyone. Thank you for coming to my talk. My name is Sally Wahba. I'm a principal software engineer at Splunk, which is now a Cisco company. Just to give you an idea of what I do at Splunk, which is relevant to our talk. So I work on Splunk Observability Cloud, which is a SaaS product. And it is deployed in multiple regions throughout the world on major cloud providers, and everything runs on Kubernetes. The services that my team owns are the ingest services. So basically, any data that comes from the customers flow through our services, and then we do some processing and then send them downstream to different observability products. So let's talk about the rise of the autoscaler. So a long time ago in 2023, in a galaxy far away down the street in Raleigh, I was an on-call engineer. Still am, but I was an on-call engineer. And my on-call shifts are a week a quarter. And the shifts ran from 10 in the morning till 2 in the middle of the night. Well, that doesn't sound too bad, right? Except when you get paged at 1:55, 5 minutes before your on-call shift ends, and you're like long asleep. So you take some time to wake up, log into all the internal needed systems, and you follow the run book while you're half asleep. You solve the problem. Hopefully you didn't add any sleep-induced errors. And that takes much longer than necessary to solve the problem. And that's also a lot of manual steps, right? So we're also expanding, which is a good problem to have. We're having more products, more customers. We're also deploying Splunk Observability Cloud in more regions throughout the world. But we're still the same group of engineers doing on-call. So that's just more work for us. And so that's not quite sustainable. And so engineers, including myself, were suffering from on-call fatigue. Even if you don't get paged in the middle of the night, it's still a lot to handle. So we decided that's enough. We're engineers. We should be able to automate a whole bunch of stuff. So we figured there's a better way. And so we started analyzing the incidents that we were having and trying to figure out how we can reduce this on-call burden. And so we looked at the different incidents that we have and the different alerts that we were getting, and we noticed that a lot of them are because of sizing issues. So in general, we run in an over-provisioned system because, again, it's a SaaS product, so we don't have as much control as we would like over how much data the customer sends us at any one time. And so when we get paged for a lot of these sizing problems, it's because the sizing, again, is not enough. And so what happens is, well, we're running in Kubernetes, so we just add more pods, and then we go to sleep. And then the next day, we try to remove these pods, maybe, if we remember, or maybe not. And so the system keeps adding more pods, and that's just more work, right? So we don't need to spend more time cleaning up after ourselves. Again, we can automate that. And if we don't clean up, well, the cloud bill keeps getting up, and that's, again, not something sustainable either. So we figured out that we need to start automating scaling. And this way we can remove the engineers from this whole process and hopefully not have to wake someone up at 1:55 in the morning. And so we figured, well, Kubernetes has autoscaling. We can leverage that. And Kubernetes offers two flavors of autoscaling. The first one is the horizontal autoscaling, which is the HPA. And basically, it's a construct that allows Kubernetes to add or remove pods as your workload changes. So as you get more data, for example, in our case, we add more pods. As we get less data, then we can delete the additional pods. And that depends on a threshold that's what we specify and tell the HPA. And so this is an image of the Kubernetes documentation. And it shows kind of how the horizontal pod autoscaling works, just adding and removing the pods. And this is directly from the Kubernetes documentation again. The second flavor is VPA, or vertical pod autoscaling. So instead of adding more pods, like the horizontal pod autoscaling, you maintain the number of pods that you have, but you add more resources. You add more memory or CPU. So one thing is the vertical pod autoscaling doesn't come by default with Kubernetes. And so we thought, well, we're running on different cloud providers. We're having all these different realms. We want something that comes by default because we're kind of new to this whole thing and we don't want to add additional stuff to figure out. And so we went the horizontal pod autoscaling route. Another thing that helped us in our services is our services are stateless, so it also made things easier so we can add and remove pods easily. So we're a bunch of dev engineers who own our services, and we kind of sort of know infra, but not quite. And so we went to our infra team and we asked for help. And we said, okay, we need this whole horizontal pod autoscaling thing, and we want to make sure that we're doing it correctly. And so they gave us a template that we could use with the internal automation that we have within our infra. And then as service owners, we needed to figure out how to use that template and basically figure out all the different configs for the horizontal pod autoscaling. And so HPA, one of the configs is you scale based on different metrics. So for example, memory or CPU or custom metrics or a combination of them. And you specify a threshold for that metric that you're using. And HPA will look at that metric. And again, if you exceed that threshold, it will add resources. And if you're below, it will delete the pods. So we're like, okay, so among the metrics, which one are we picking? And so we picked CPU. We could have gone a fancy way of doing custom metrics, but again, we're new to this whole thing and we don't want to overcomplicate things. And another reason we chose CPU is our services already had memory guards. So we didn't, like, memory wasn't really an issue causing us trouble. And looking at the different alerts, we were getting alerted for CPU utilization a lot more than memory. And so that's why we chose CPU. So another thing to consider is how many containers you have in your pod. So one limitation that HPA had was it would sum up the total utilization among the different containers. So it's possible that you run into a situation where one of the containers is running hot, but the total utilization for the pod is still under the threshold you specified. And so you can still run into trouble of your container is struggling, but HPA is not kicking in and adding more pods for you. So that's something that we had to think through of what containers do we have, what are the issues that we're running into, and what threshold are we setting. Luckily, starting Kubernetes 1.30, there is a way for you to specify per container metrics, and that is pretty useful, except that we didn't run 1.30 at the time, and we usually don't use a feature that is not quite stable yet. So starting off, we, again, chose the CPU. So the next thing we needed to figure out with whole horizontal pod autoscaling thing is figuring out the minimum and maximum replica. So that's basically a way that tells HPA, hey, do not scale down below a certain number of pods. So in our case, for example, we want to make sure that our service is available. So we're deployed in different availability zones, and we kind of put our resources that way. And so we have a minimum number of replicas that we're running with. And then at the same time, you need to tell it the maximum number of replicas you're going to have. Because in our case, we're on ingest services. There are downstream services. We want to make sure that we scale up to a point where we don't cause an outage to the downstream services as well. And so that's something that we needed to figure out. And the other thing that we also needed to figure out is, like I said, Splunk Observability Cloud is deployed in different regions, and each region has its own size because each region had different number of customers with different data coming in. And so we needed to figure out these numbers per region. So we can't talk about Kubernetes without showing some YAML. So here is an example of the YAML config for horizontal pod autoscaling. Again, this is coming from the Kubernetes documentation, but it is very, very similar to what we've used. So the first thing, it specifies that they're using horizontal pod autoscaling. The next thing is we're creating it for, the documentation says PHP Apache deployment, but in our case, it's one of the ingest services. The next thing is you specify the minimum and maximum replicas. And then you tell it, like in our case, we're telling it, hey, we're looking at CPU utilization. This is the metric that you're looking at. And we want you to have a target utilization of 50% for CPU. And since we had that maximum replica set, which is basically the upper limit that we wanted to have for our deployment, we needed to add a detector, which is basically a way for us to monitor the resource utilization, because we want to know if we reach that maximum replica count, because we might be running into sizing issue again and we might be on the verge of an outage. And so that's something we wanted to be alerted on. And now what? So we enabled horizontal pod autoscaling. And since we've enabled it, the different alerts that we get with respect to sizing have reduced to by 75%, which is pretty fantastic. And also other service owners and other teams within our organization started adopting horizontal pod autoscaling as well. And that led to our infra team adding more support internally for our tooling as well, which is, it's pretty cool. So in summary, we started off by showing how on-call was pretty brutal. I don't want to be woken up at 1:55. We covered some Kubernetes concepts and how we used horizontal pod autoscaling, kind of the thought process that we went through. And then we covered the results and the gains that we've had. We certainly are using super basic configurations. We can make it more complex, but I don't know, for 75%, that's pretty good. That's pretty good improvement for us. So right now, we don't feel the need to do that. I no longer get paged at 1:55. And that's it. May the HPA be with you. Thank you.